And good afternoon, good evening, or good morning, depending on where you are and when you're reading this lecture. What we're going to do next in our next uh, lesson or our next concept, this is going to be a shorter video than normal because we're not going to do a whole lecture. This is just going to be a bite-size uh, um, topic, and what we're going to be talking about today is residual astigmatism. And in the residual astigmatism, this is an unbelievably important concept because we've talked about um, corneal measurements. We're taking keratometry in labs. We've done topography. We actually have looked at how to interpret some of the maps in a basic introductory way. And we know if it's steeper, if the meridian is steeper up and down, you get that red steeper meridians up and down. Uh, and the flatter, therefore, would be side to side. That would be a with the rule astigmatism or with the rule cornea. If it were steeper back and forth at the 180 or give or take 30 degrees, that would be an against the rule. And you can think of it a number of different ways. You can memorize steeper up and down or steeper back and forth, which is which. You can think about it on the contact lens if you're talking about a rigid gas permeable, generally rides or moves along the steeper meridian, and we want it to move up and down if we can, generally. And with the rule, corneas tend to be a little bit more better suited to that. We have the topographical map, obviously the shape of, if it looks like, if you see that little steepness, if it looks like a regular tie, that would be a with the rule because it's normal-ish, if you will. And the one that goes across bow tie is a little bit less customary, and we would call that against the rule. There are different ways to do that. But we're talking about the shape and the amount of astigmatism on the cornea itself. And the eye, as we know from biology and anatomy and physiology of the eye, the uh, total amount of astigmatism is not only found generally, it may be found in other places outside of just the cornea. The cornea is the main refractive index, refractive structure, we know that. And it's about 2/3 of the refractive structure, total refractive power of the eye. But there are other refractive portions of the eye, including the crystalline lens or the shape of the eye. And there's a handful of different things that can contribute to the total amount of astigmatism in a person's eye. So it's not just how much astigmatism is in the cornea gives you the total amount of astigmatism in a person's refraction or in their prescription. And generally it matches up pretty well, but sometimes it doesn't. And when it doesn't, we call that residual astigmatism. And residual astigmatism comes in a couple different names. You'll see it in different texts, in different articles, and it'll say things like residual astigmatism, lenticular astigmatism. That's because the primary refracting surface outside of a refractive structure outside of the cornea is the lens. And if there's any misalignment or shape or something to that effect where it's causing additional astigmatism, there's a good chance that a large portion or the majority of anything that's not corneal may in fact be coming from the lens, ergo lenticular astigmatism. Internal astigmatism, you'll sometimes hear that used. So again, residual astigmatism, internal astigmatism, lenticular astigmatism, for all practical intents and purposes for us today, that's essentially going to be interchangeable. We'll use the residual astigmatism just because to keep things standardized in our class. But what you're looking at is, forget the definition, it's what is it? And essentially, we generally can look at the total amount of astigmatism in a system or in a prescription or in an eye. And this is generally if the doctor gives us the refraction and it has a two sill, let's say it's a with the rule astigmatism, and let's say it was a -2 axis 180. Ignore for a moment the spherical portion. What we're talking about is just the astigmatism portion. We know that we have 2 diopters of sill axis 180 or with the rule. And so this is essentially what we're looking at. Just separate the cylinder component out. Forget at this point, forget the spherical component. We don't care if it's a plano, a simple myopic astigmatism. We don't care if it's compound, hyperopic. I'm sorry, compound myopic. We don't care if it's a mixed astigmatism. We only know and care at this point that the total amount in this eyeglass prescription is 2 diopters of with the rule astigmatism in this particular given refraction. Now, there's 2 ways that this can come from. Generally, the majority will come from the cornea, and we measure that with our topography. We measure it with keratometry, what have you, and generally the amount of astigmatism we find is relatively similar to the cornea, but not always. And there's generally only 2 places that astigmatism can come from, the cornea and essentially everywhere else. And this is anything inside the shape of the eye. It can be the, let me just move this over ever so slightly so you get a slightly better view. Sorry about that. But generally we can call this anything inside the eye that's contributing to the amount of astigmatism that's not the cornea. And we'll use for this purposes residual astigmatism plus anything that's left over, or internal astigmatism. Essentially, it's either coming from the cornea or from the inside of the eye, or whatever's left, whatever else is contributing to this total amount of astigmatism. So essentially, you just do it with a math formula. If your corneal readings are 42 and 44 at 90, so it'd be a 42 at 180, flatter, 44 at 90, so it's steeper, and the difference between these two, the delta K, if you will, is 2 diopters of with the rule, and that's axis 180. Well, whatever's in the prescription, it's a combination of whatever in the cornea and whatever's left over inside. Well, in this case, the total astigmatism we have is 2 diopters. We have 2 of it from the cornea, so there really isn't any internal astigmatism. There's no contribution. There's no lenticular, there's no other astigmatism inside, internally in the eye. It's all coming from the cornea. Now, in a perfect world, if we're doing gas permeables, this is our best case scenario. And the reason for that is, as we've learned with our basic introductions to gas permeable spherical lenses, if I put a spherical lens on a toric cornea, generally the amount of corneal astigmatism will essentially establish how much astigmatism in a tear lens under that gas permeable lens we're going to get. And if it gives me a 2 diopter tear lens, and I need 2 diopters in my prescription, this is actually going to work remarkably well. The less residual astigmatism I have, the better. And so this is just the overview of the idea of residual astigmatism. We've been so focused on the cornea, but there's more to the eye than just the cornea. There's more to the refractive power than just the cornea. Now, this we take it as whatever is in the prescription. This we take in the measurement, but this is something that we calculate and we can determine. Now, another way to write this is if I simply subtracted the corneal astigmatism from both sides, I would isolate this residual. So instead, we can write it like I want to find my residual astigmatism. We're going to just use RA is simply the total refractive astigmatism, and this is simply what's in the spectacle Rx, what was written. In our last example, it was 2 diopters with the rule. And we're going to subtract the corneal astigmatism, and that's just our delta K. So in our last example, the amount of residual astigmatism was simply, and we'll just write this, so the total refractive astigmatism is simply what's in the Rx. This is from my K readings or my topography. And we're trying to figure out how much of our astigmatism that's in our prescription is not from the keratometry values, or not from the topography, or not from the cornea. How much is internal? How much is lenticular? How much is left over? How much more is the internal structures? How much of the internal structures is contributing to the amount of astigmatism? Now, in our last example, we had 2 with the rule, and we subtract 2 with the rule, and our argument was we had the 42 at 180, we had the 44 at 90. That was 2 diopters with the rule, In the prescription, we had 2 diopters with the rule. This minus this gives us none. 2 minus 2 in the same direction with the rule, and these have to be the same. We'll get into some more complicated examples. The residual astigmatism in this patient is 0. Now, why do we worry about this? Why am I throwing this at you? And that is, if we put a rigid gas permeable spherical lens on a corneal, on a cornea, it's going to create a tear lens that's equal to the amount of corneal toricity, or the delta K. So I get a two diopter with the rule tear lens. My patient needs a 2 diopter with the rule amount of astigmatism. As long as we hit the spherical component of the contact lens between the tear lens and the power of the contact, this person, and its vertex, this person is going to see really, really well, arguably. Now, why is it important? Because if we have someone who has a significant amount of residual astigmatism, and another way to look at residual astigmatism is how much astigmatism is left after we put a gas permeable on. Meaning, if I put a gas permeable on and it gives me some amount of astigmatism because of the tear lens, how much of the actual prescription is corrected, and is there any left over? If I have a big amount of residual astigmatism, I'm going to have uncorrected refractive error, and my gas permeable may not give me the crisp, sharp optics that I'm really looking for. So let's give another example. So if this is our formula, let's give another example. So we're going to do something along the lines of, I have a minus 2 again, and let's say it's a minus 2 again, same prescription. The amount of astigmatism, the amount and direction, is 2 diopters with the rule. And let's say my K readings are 41 at 180. And now we're going to do 42 at 90. In this case, what's my delta K? Well, the difference from delta K, my flat K reading, or my K reading, my flattest K is 41. My steeper is 42. So the difference for this, my delta K, therefore, delta K equals 1 diopter of with the rule astigmatism. Well, 1 diopter with the rule and 2 diopters with the rule, they are not the same. They're different. So the practical application of this is, if I put a gas permeable sphere lens on this eye, it's going to give me approximately 1 diopter with the rule astigmatism because of that tear lens. My biggest problem is my RX, I need 2 diopters and it's only giving me 1, and in a spherical gas permeable lens simply won't provide enough any other source of astigmatic correction. We're going to have to find another way to put that in, and we'll get to what those options are, whether it's a front surface toric gas permeable, whether it's a soft toric lens, makes no difference, but let's use these two. So we're going to take this 2 with a rule for my total refractive astigmatism, my total of what's in the RX. We're going to subtract what's in the keratometry, and so in this case, recall in this example, I had 2 with the rule, I subtracted 1 with the rule, 2 with the rule, minus and take away 1 with the rule, it leaves me with 1 with the rule, or 1 at 180. And what this simply means is I have 1 diopter of astigmatism built in somewhere inside the eye that's not from the cornea. I have 1 diopter that if I put a spherical lens on, that's a gas permeable, it will in fact create a tear lens that does in fact have astigmatism, that is in the same orientation as what the prescription was. It just wasn't enough, and they needed more. So essentially, with the rule of residual astigmatism, if the delta K, amount and direction, do not match exactly the refraction, amount and direction, you have something left over. You have astigmatism that's being created inside the eye, and that's a big concern. So what we're going to do is, this was just a quick overview to supplement the reading, to supplement the article, and we're going to do a couple examples of, we'll give you how much is in the RX, we'll show you what is the delta K, how much, and what we're going to simply do is have you calculate the difference. If it matches up, great. There isn't any. It should work as a GP. I would argue For our purposes, for this class, and I'll explain to you why, as long as the residual astigmatism is essentially less than a half a diopter of residual astigmatism, the sphere, the gas permeable sphere lens should work relatively well enough to provide good visual acuity for our purposes. Once you start getting over a half a diopter of residual, one diopter in this case, anytime you have 3/4 of a diopter, one diopter, more of residual astigmatism, the optics and the benefits of our improved vision from a gas permeable spherical lens, they're simply not there anymore. It's less of it's less of a benefit for some of the benefits that we said that a gas permeable brings to a spherical gas permeable lens brings to the party. We'll get into this a little bit more with some of our readings, but I just wanted to give you a quick 15-minute burner lecture on what this residual astigmatism and why this formula exists the way it is, because this is what's in the RX. It's a matter of the total refractive astigmatism, or the refraction, the cylinder in the RX is the same as the residual plus the keratometry value. But if we rewrite the formula, the residual is simply whatever I have in the RX, subtract from the keratometry, and that will be my residual. So we'll give you some examples, and hopefully this was helpful. And again, as always, you can always email me via Blackboard with any questions. Talk to you in a bit.